Hello,
Yes, sir.
can you hear me?
Yes, sir.
Okay. Have you tried the assignment, number theory?
Yes, sir.
So tell me which ones you have done, which ones are difficult.
Okay, sir. 1 minute. Sir, second one I was not able to done.
First one is obvious, right?
Yes.
It is coming as perfect square.
Hmm. 2 to the power 11, 3 to the power 12.
Hmm. Okay. Second one is saying prove that uh, by inserting any natural number of ones. Yeah. Prove that by inserting any natural number of ones between the second zero and the 3 in 1003, we obtain a composite number. Okay. So we are saying after the second zero, we are putting ones, right?
Yes, sir.
Let's say we put k ones. K is a natural number, correct? So we have put
Hmm.
k ones. So how many total digits are there? K plus 4, right? Correct? No?
Yes, sir.
K plus 4 digits are there. So you will get, this will be 1 into 10 to the power k plus 3 plus 0, and 0 will not count. After that, it will be, the next one will be 1 into 10 to the power k. Those k plus 2, k plus 1 are gone, right?
Hmm. Hmm.
And then it will be 10 to the power k minus 1 and so on till 10 to the power 1 plus 3, right?
Yes, sir.
Okay. This is our number. We have to prove that it is composite.
Hmm.
So we can think of this as 100 into 10 to the power k plus 1 plus 10 to the power k. This is a GP.
Hmm.
There are how many terms? K terms.
K terms.
Our first term is 10, right?
Yes, sir.
So GP sum can be done.
Hmm.
We'll do the sum of the GP. We'll say 10 into A into R power n. So 10 power k minus 1 divided by 10 minus 1, right?
Hmm.
Do you understand what I'm saying?
Yes, sir.
Plus 3. So technically, this is looking like 10 power k plus 1 minus 10 by 9 plus 3.
Hmm. Hmm.
So we can say minus 1 minus 9, right?
Yes, sir.
एक 9 को बाहर निकाल सकते हैं, right?
Hmm. Hmm. Hmm.
10 power k plus 1 minus 1 by 9
Minus 1.
or minus
Minus
1,
9
so
by 9.
plus 2.
Hmm.
So we are getting 100 into 10 power k plus 1 plus 10 power k plus 1 minus 1 by 9 plus 2. Correct?
Yes, sir.
Okay, this expression we will simplify. Uh, we will get, taking 9 common everything, and we'll get 900 into 10 power k plus 1 plus 10 power k plus 1 minus 1 plus 18.
Plus 18.
So this is becoming 901 into 10
7.
power k plus 1, right? And plus
Yes, sir.
17 divided by 9, right?
Hmm.
Okay, so 901, this number, uh, you can see that it is divisible by 17. 17 5 is
Yes, sir.
85 and then 3, right?
51. Yes.
53.
We can take 17 common and
So 17 common, it is coming 53 into 10 to the power k plus 1 divided by 9,
hmm.
right?
Yes.
So that automatically proves that 17 divides that
Hmm.
number. No?
Yes, sir.
17 is a divisor,
Hmm.
which means that the original number is not prime.
Hmm.
This, okay, this will be true if we have to probably prove that this is an integer also, right?
Oh, yeah.
It should be an integer, right? So let's think about it. I think it is easy to show that this is an integer because this is 10 to the power k plus 1 can be written as 1 plus 9 to the power k plus 1, right?
Hmm.
53 into that plus 1, right? So notice
Hmm.
that constant term is the only term that is doubtful, no? Other terms are divisible by 9.
Yes, sir.
तो 53 कांस्टेंट आएगा और प्लस 1 हो जाएगा.
तो वो भी डिविजिबल हो जाएगा.
54 plus stuff which is divisible by 9.
Hmm.
So that proves that this thing inside is an integer. That means it's a product of
Yes.
two integers.
So
Which
it
means
can't be
that,
prime. It has to be
uh,
composite. Hmm.
okay, what is the next one? That is not solved.
Wait. In question 6, like I found the solution, but I was not able to bound the solution. Like only these are possible that I was not able to do.
You've not been able to prove that only those are possible.
Yeah, like I found that P P congruent to 5 mod 8, Q congruent to 3 mod 8, and R congruent to uh, minus 1 mod 8. But
Mhm.
only these are possible. Like
3,
not
4, 5
P.
is done. 3, 4, 5.
Yes, sir.
Okay.
Oh, actually
Let
5, 5. Actually 5 also. Sorry, 3, 4 done. 5 not.
question 5 is saying that if ABC and A power 4, okay, if
So can you
A,
confirm
B,
the answer of 3 and 4? Answer for 3 is 13 and minus 11.
1 second, find all integers for which answer 13 and minus 11, yeah,
And
and
for fourth, it is 1.
hmm,
Hmm.
okay, that is correct. ABC and A power 4 plus B power 4 plus C power 4 minus 3 are prime. Then show that A square plus B square plus C square minus 1 is also a prime. Okay.
Hmm.
So, right. So A, B, C and this number are prime. So usually primes are odd. So we should first take the case that A, B, C
Then,
are all odd. The only exception is 2.
hmm.
So right now we are saying that none of them is 2. They are all odd.
Hmm.
So if they are all odd, then you will realize that this is the sum of 3 odd numbers and subtract 3 from there. Odd minus odd, this is even, right?
Oh, yes, sir.
So,
So it
and
can
it is
be
obvious that
only
it will
true.
be greater than 2. Why is it obvious? Because odd primes are going to be 3, 5, 7 at least, right?
Hmm.
It is greater than 2, so that doesn't work, right?
Hmm. So
Because
one of
it's a
them has to be even.
so basically the point is that this number is an even number bigger than 2,
Hmm.
so it cannot be prime. So that's a contradiction,
Hmm.
right? So that means
Yes.
that A, B, C, all of them cannot be odd,
Hmm.
right?
Yes, sir.
So without loss of generality, we will assume that one of them is 2. Let's say A is 2, right?
Hmm.
Now what we are getting is, if A is 2, now we can say that this will be fine because now we are not getting an even number here, right?
Hmm.
Because we are getting 13 plus B power 4 plus C power 4 is prime.
Hmm.
B and C are odd, so this is adding up to an odd number, right?
Yes, sir.
Correct?
Hmm.
So we are taking the case A is 2 and B and C are some odd primes. So
Hmm.
now we are getting that 13 plus B power 4 plus C power 4 is prime. Now, obviously, since B and C are prime, B and C are not multiples of 3, right?
Yes, sir.
B will be either 3k plus 1 or 3k plus 2,
Hmm.
right? So
Hmm.
then if you do B square, if you do B square mod 3, let's think about it. What is coming here? 9k. It is 1 mod 3 in this
Hmm.
case.
Hmm.
And in this case, what is coming? It is also 1 mod 3.
Again, one mod 3.
So we are getting B square is both 1 mod, both cases is 1 mod 3, right?
Hmm.
Similarly, we are saying that both B and C are not multiples of 3, obviously. So both B
Yes,
square and C square will be 1 mod 3, right?
one mod 3.
It is guaranteed. There's no doubt in that, right?
Hmm.
Because B and C are prime, right?
Yes, sir.
तो ये जैसे ही आया तो आ गया B power 4 plus C power 4. B power 4 and C power 4 are also 1 mod 3.
One mod 3.
So 1 mod 3, 1 mod 3. And the sum will be 2 mod 3. And
हाँ.
this is what? This is 1 mod 3, right?
Hmm.
Correct?
Yes, sir.
तो ऐड होके तो 3 mod 3 हो जा रहा है.
हाँ.
So divisible by 3 आ जा रहा है, right?
मतलब नहीं हो सकता.
Which means it's not possible. So that means this stuff is wrong. So one of them must be a multiple of 3, right?
Hmm.
But since it's a prime, one of them has to be 3 then.
Yes, sir.
It can't be a
So,
multiple of 3, right? It has to be 3.
hmm.
Do you understand that first we said that A was 2
Yes, sir.
by checking the
Now
odd
we
and
get
all?
that.
Uh,
Now we get one of them is 3.
so now we'll say without loss of generality, B is 3.
Yes, sir.
यहाँ पे हम लोग ने mod 2 देखा था, even odd, right?
Hmm.
उससे
Mod
आया
3.
कि a is equal to 2. अब mod 3
Hmm.
देख के b स्क्वायर और c स्क्वायर का आ रहा है 1 mod 3. तो
Hmm.
उससे आ रहा है कि this is not possible unless one of them is 3.
क्योंकि डिविजिबल तो हो नहीं सकता क्योंकि
हाँ.
प्राइम है. Hmm.
तो as soon as b is 3 now, we will say that same expression now will calculate 13 plus 81 plus c power 4. So you're getting 94 plus c power 4 is prime,
Hmm.
right?
Hmm.
And now we should look at mod 5 because the next prime is 5, right?
Yes, sir.
We'll see mod 5. So we don't know C. We know that C is not a multiple of 5, right? So C
Hmm.
can be any of the form 4k plus 1, 5k plus 1, 5k plus 2, and so on, right?
1 to 4.
1
Hmm.
to 4. So C square का देखो क्या आ रहा है. C square का आ रहा है, क्या क्या पॉसिबिलिटीज है. 1,
1,
4,
4.
फिर 3 में क्या आ रहा है. 9, 4 बस. और
वही
4
1
में
और
क्या आ रहा
4.
है. 1 आ रहा है. 1 और 4 आ रहा है.
Hmm. Hmm.
राइट. सो
और
सी
C
पावर 4 का क्या आ
वो
रहा है.
सिर्फ 1.
1 और 4 स्क्वायर आ जाएगा 16, वो भी 1, राइट.
1.
So
Hmm.
C power 4 आ रहा है 1 mod 5, and if you
Hmm.
add to this, what is coming? It is coming as 4
5
mod 5 plus
5
1
mod
mod 5. So 5 mod 5,
5
which is
mod
not
5,
possible.
तो वो फिर C 5 हो जाएगा। सही
इससे
है।
पता चल रहा है कि ये 5 mod 5 पॉसिबल नहीं है, प्राइम नहीं हो रहा है, तो C
हाँ।
has to be a multiple of 5 now. The only
हम्म
possibility is it has to be equal to 5.
हम्म
सो सेम लॉजिक से एक एक करके हम लोग ने A, B और C फिक्स कर लिए,
हम्म
राइट?
यस
And
सर।
now that we know that A is 2, 3, now you can check this. It will come out to be 4 plus 9 plus 25. So 38 minus 137,
हम्म
which is also a prime.
हम्म
Is it clear?
यस सर।
Okay.
6 भी हो जाएगा, 6 भी हो जाएगा।
सिक्स में सिक्स में मॉड लेने की जरूरत नहीं है एक्चुअली. आई थिंक there is a
ओके
better way to do it. One second. Let me see the
ओके।
question. Find all positive integers R such that they resist primes P and Qs. Okay. Find positive integers R such that there exist primes P and Q, primes P and Q, such that R square is equal to P square plus PQ plus Q square. Okay.
यस सर।
Okay. So इसमें हम लोग फैक्टराइजेशन कर सकते हैं, बिकॉज वी कैन से दैट दिस इज
हम्म
p plus q whole square minus pq,
हम्म
right? And we can
हम्म
say pq is equal to p plus q whole square minus r square.
हम्म
तो उससे आ रहा है pq is equal to p plus q plus r and p plus q minus r, right?
हम्म
So इससे क्या पता चल रहा है कि p plus q plus r is a divisor of pq, right?
हाँ।
And that is, this divisor is larger than P and Q, right?
हम्म
Larger than P and Q, correct?
यस सर।
But P and Q तो प्राइम थे, प्राइम का प्रोडक्ट थे,
हाँ।
राइट? तो
हम्म
इससे लार्जर कोई और डिवाइजर होगा नहीं एक्सेप्ट पी क्यू, राइट?
हाँ
डू यू अंडरस्टैंड व्हाट आई एम सेइंग?
हाँ हाँ समझ।
द ओनली लार्जर डिवाइजर ऑफ पी क्यू इज पी क्यू only.
पी क्यू ओनली।
So we can say that this must be equal to PQ, and then this is automatically equal to 1,
हम्म
right?
यस सर।
So we are getting two equations. P plus Q plus R is PQ. We are getting P plus Q minus R is 1. Do you understand the logic of how?
हम्म
If you add these two, you will get 2 times P plus Q is equal to PQ plus
पी
1.
क्यू प्लस 1।
And now we will do the factorization method that you should know. Uh, it's called Simon's favorite factoring trick. So basically what will you do? PQ minus 2P minus 2Q plus 1 is 0, right?
हम्म
तो यहाँ पे इसमें से फैक्टर ले लेंगे P Q-2, और यहाँ पे हमको Q-2 ही रिपीट करवाना है, तो उसके लिए +4 होना चाहिए था, राइट?
+4। हाँ।
-2Q +4 डाल देंगे और -3 कर
हम्म
देंगे, राइट?
हम्म
तो यहाँ पे -2Q-2 और यहाँ P Q-2 इज इक्वल टू 3, राइट?
हम्म
वी आर गेटिंग P-2 इंटू Q-2 इज इक्वल टू 3,
हम्म
राइट?
यस
एंड
सर।
3 इज अ प्राइम नंबर, सो प्रोडक्ट ऑफ टू में तो 3 और 1 ही हो
या तो
सकता है,
3
right?
होगा या 1 होगा। हाँ।
So it has to be written as P minus 2 is 3 and Q minus 2 is 1, or
हम्म
P minus 2 is 1 and Q minus 2 is 3, right?
हम्म
So P
हाँ।
is 5 and Q is
क्यू इज
3,
3।
or vice versa.
यस।
So ये प्रूफ है, इसमें और कुछ
हम्म
डाउट नहीं बचा फिर. और जैसे ही ये पता चल गया P और Q का वैल्यू, तो हमको R भी पता चल जाएगा यहाँ से.
हम्म
या फिर यहाँ से आर आ रहा है 7,
हाँ।
एंड दैट इज द ओनली सोल्यूशन।
हम्म।
तो लॉजिक क्या था, यहाँ पे फैक्टराइज करके ये आया था।
हाँ,
ये आने के बाद ये बोल सकते
वहां पे
हैं
वो
कि
देखना था कि वो प्रोडक्ट या तो वो
हाँ,
बराबर पे होगा, उससे बड़ा नहीं
ये
होगा।
इसमें देख सकते हैं कि ये जो नंबर है, इसमें जो फैक्टर्स के रूप में लिखा गया है, दिस
हम्म।
फैक्टर कैनॉट बी, दिस इज अ बिगर फैक्टर देन पी एंड क्यू,
हम्म।
and since p and q are primes, there is no other factor other than 1 p q and pq.
हम्म।
So this must be
हैज
pq,
टू बी
this
इक्वल।
must be 1।
हम्म।
और उसके बाद ये इक्वेशन आ गया, उसके बाद ये आ गया, और उसके बाद उसको
फिर तो।
सिंपली ऐसे फैक्टराइज कर दिया।
हम्म।
ओके,
हम्म।
व्हाट इज द नेक्स्ट वन?
सर नाइन्थ। सर व्हाट इज द आंसर फॉर सेवेंथ?
1 second. P and q are twin primes. P plus q is equal to 84.
यस सर। एंड सर व्हाट इज फॉर एट?
P square plus 2013q. 2 comma 2011 या 2011 comma 2।
हाँ वही। हाँ, नाइन्थ नहीं हुआ।
Okay. Question 9 says that prove that there are infinitely many pairs PQ of primes such that, okay, prove that there are infinitely many pairs of primes P comma Q such that P power 6 plus Q power 4 has two positive divisors whose difference is 4pq. Okay. uh, right. बहुत there are infinitely many pairs of pq prime such that this thing has two positive divisors whose difference is 4pq. तो this is a problem where इस टाइप का एक्सप्रेशन देख के ही और डिफरेंस 4pq देख के ही तुमको हिंट आना चाहिए सोफी जर्मेन आइडेंटिटी का।
हम्म।
यू नो दिस, ये फैक्टराइजेशन इसका होता है। इसको फैक्टराइज कर सकते हैं, इसको ऐसे लिख
हम्म।
सकते हो, you can add a term to make it perfect square and then subtract it, right?
हम्म।
तो इसमें फर्स्ट थ्री टर्म्स क्या हो जाएंगे, ए स्क्वायर प्लस 2b स्क्वायर का होल स्क्वायर
हाँ।
माइनस 2ab का होल स्क्वायर।
हम्म।
तो अब क्या हो गया, ए स्क्वायर प्लस 2ab प्लस
वही
टू
भी।
बी स्क्वायर
हम्म।
multiplied by a square minus 2ab plus 2b square. Can you see that the difference between the factors is 4ab?
हम्म। हम्म।
तो वही से देख के, ये देख के और ये पावर 4 देख के हिंट आ रहा है कि सोफी जर्मेन शायद होगा।
ओके। ओके।
समझ में आ रहा है?
हाँ हाँ।
इस चीज का फैक्टराइजेशन इनटू टू फैक्टर्स सच दैट देयर डिफरेंस इज 4ab।
हम्म।
सो but Sophie Germain requires a 4 times b power 4 type of thing, right?
हम्म।
So that is where you have to be a little clever because q power 4 तक तो ठीक है, इसके लिए
हाँ।
क्या करेंगे, right?
हम्म।
Do you understand what I'm saying?
हाँ।
तो इसके लिए करेंगे कि we will fix the p as a prime number 2
ओके।
because p is a prime number 2 will make it work out very nicely
हम्म।
because what will you get, q power 4 plus 2 power 6, right?
हाँ।
और 2 पावर 6 को ऐसे लिख सकते हैं, q पावर 4 प्लस 4 टाइम्स 2 पावर 4।
हम्म।
तो अब देखो फॉर्म पूरा आ गया सोफी जर्मेन
हाँ।
वाला।
हाँ.
इसमें Q is my A and 2
हम्म.
is my B, राइट? तो इसको ऐसे लिख लेंगे अब,
हम्म.
फैक्टराइज करके। इसमें आएगा Q² प्लस 2AB, सो 4Q आ जाएगा प्लस 8। और इधर आएगा Q² माइनस 4Q प्लस 8, राइट?
हाँ.
द डिफरेंस ऑफ दीज टू इज 8Q, राइट?
हम्म.
8Q is the difference, which is actually 4 times 2 into Q, right?
हम्म. आ गया.
4PQ.
हाँ.
Basically, P को fix कर लो 2 and Q can be any prime.
हम्म.
So any set of primes like this are solutions.
ओके.
We have proved by factorizing this thing that we are getting two factors with difference 4PQ, right?
हम्म.
So main thing is to know Sophie-Germain identity. This is a very famous identity. This you need to know.
हम्म.
और वो अगर पता है तो ये डायरेक्टली उससे हिंट आ रहा है.
हम्म. ओके.
Is it clear?
यस सर.
Okay. What is the next one? Next one that is a problem.
सर 10th.
Okay. Let let P be a prime such that 2P² plus 1 is also a prime. P is prime. 2P² plus 1 is also a prime. We have to prove that 2P² minus 1 is also a prime. Okay. Fine. तो इसमें मॉड्यूलो यूज करते हैं. वी
अच्छा,
कैन से,
जैसे वो क्वेश्चन में करा था.
हाँ जैसे वो क्वेश्चन में किए थे. वी कैन से इफ p is not equal to 3, right?
हम्म.
Then it will be a number that is not divisible by 3, right? Obviously,
हाँ.
because it's a prime, right?
हम्म.
So
हम्म.
then we saw earlier that p² is congruent to 1 mod 3.
हम्म.
देखो 2P² plus 1 क्या आ रहा है?
2P² 3 3 3 के कन्वर्ट 0 मॉड.
तो it cannot be a prime contradiction, right?
हम्म.
उससे क्या पता चल रहा है
कि एक भी नहीं है.
कि p is 3?
हाँ, मतलब 3 का कोई मल्टीपल नहीं है 3 का.
p क्या 3 का कोई, p is not equal to 3 के केस में हर समय यही हो,
हाँ.
राइट?
हम्म.
प्राइम नंबर्स का स्क्वायर का मॉड ऐसे लेके, ये एक टेक्निक समझ में आ रहा है,
हाँ.
जैसे वो उस क्वेश्चन में भी किया था.
फिफ्थ में जैसे हुआ था पूरा.
हाँ. तो इससे
हम्म.
पता चल गया p is 3, और चेक करो देखो 17 आ रहा है.
हाँ, हो गया.
तो सिंपल ही है, बस ये वाला आइडिया होना चाहिए.
हाँ, वो तो उस समय नहीं दिखा.
नेक्स्ट कौन सा हुआ
फिर 14.
है? Prove that any composite number can be written as, okay. Prove that any composite number can be written as AB plus BC plus CA plus 1 for some positive integers A, B, and C. Any composite number can be written like this. Okay, so usually कॉम्पोजिट नंबर को कैसे लिख सकते हैं? कॉम्पोजिट नंबर को प्रोडक्ट ऑफ टू नंबर्स के तरफ
Product of
लिख
two
सकते हैं।
numbers. Hmm.
एक्स वाई लिख सकते हैं वेयर एक्स एंड वाई आर बोथ ग्रेटर देन इक्वल टू 2।
Hmm.
ओके, सो यहाँ पे we have to write it like this somehow. So since x and y are both greater than equal to 2, we can write x as a plus 1 and y as b plus 1, right?
Hmm.
Because that will ensure that a and b are greater than equal to 1, which is
Hmm.
fine. Correct?
Yes, sir.
तो ऑटोमेटिकली इस एक्स वाई को हम लोग ऐसे लिख सकते हैं a प्लस 1 टाइम्स b प्लस 1, राइट?
Hmm.
करेक्ट, विच इज ए बी प्लस a प्लस b प्लस 1, राइट? करेक्ट।
Yes.
और इसमें अगर इस एक्सप्रेशन में c1 होता तो वो क्या होता?
यही बन जाता.
So basically we can say that a, b are any integers greater than equal to 1. We can always find such integers for any
Hmm.
composite number, right?
Yes,
And
sir.
c is 1. Do you understand क्या हो रहा है?
हाँ.
अगर मान लो एक composite number 24, उसको तुमने बोला 6 into 4, right?
Hmm.
उससे हमको a पता चल गया 5 and b 3।
हाँ.
तो अब उसको ऐसे लिख सकते हैं 5 into 3 प्लस 5 प्लस 3 प्लस 1।
हाँ.
और इसी को लिख सकते हैं 5 into 3 प्लस 5 into 1 प्लस 3 into 1 प्लस 1।
Okay. हाँ.
So basically we have expressed that 24 as this, right?
Hmm.
Basically we are saying any two divisors, उसका अगर divisors greater than equal to 2 तुमने लिखा है, right?
हाँ.
Any composite number can always be written like this.
Hmm.
अगर प्राइम होता तो ये पॉसिबल नहीं था, राइट?
नहीं.
लेकिन कॉम्पोजिट है तो ऐसे तो लिख ही सकते हैं, और ऐसे लिख सकते हैं तो a प्लस 1 और b प्लस 1 बना सकते हैं उसको।
Hmm. Hmm.
Do you understand?
हाँ. Yes, sir.
Okay. What is the next one?
18th.
Okay. Find all positive integers such that n, n plus 6, n plus 8, n plus 14, यही है ना? One second. हाँ, n plus 14 and n plus 2012 are all prime. Okay. Hmm. So they have given us 5 numbers, right? And all of these 5 numbers are supposed to be prime. Do
Hmm.
you understand what I'm saying?
Yes, sir.
क्योंकि 5 numbers दिए हैं, I will think of it modulo 5.
Hmm.
So right now what we are getting are, these are congruent to n, n plus 1, n plus 3, n plus 4, and n plus 2 mod 5.
Hmm.
Can you see that these are all coming?
Yes, sir.
So this is a set of 5 consecutive numbers. देख रहे हो?
Hmm.
Set of 5 consecutive numbers,
हाँ.
right? So at least one of them is divisible by 5, right?
Hmm.
One of them is divisible by 5. How am I so sure?
क्योंकि
Because
कोई तो एक 0.5 होगा, लाइक
n
5
को
से
तुम
डिवाइड
n को
करके।
तुम assume कर सकते हो 0 to 4, right?
हम्म
No matter what you assume, one of them will be divisible by 5,
हम्म
right?
यस
So
सर।
at least one of these numbers is divisible by 5.
हम्म
Now हमको पता है कि all of them are prime, right?
हाँ
All of them are prime, or last four of them are clearly bigger than 5.
हाँ, ओनली n कैन बी 5।
Hmm. N must be 5 then, right?
हम्म
One of them is divisible by 5. You cannot have these ones divisible by 5, right?
हम्म
So this has to be divisible by 5,
यस सर।
correct? And that
यस।
means N is 5, right?
हम्म
As soon as you get N is 5, you can now see that 5, 11, 13, 19, and 2017 are all prime.
हम्म
Check and see that they are all prime. So therefore, this is our solution.
ओके।
It is not
मतलब
possible to have any other solution because multiple of 5 उससे ज्यादा तो prime बनाना है ना.
अच्छा, हाँ हाँ
We cannot take a other multiple of 5.
हाँ, ये 5 आ गया था, बट मैं ये नहीं सोच पा रहा था कि इसके अलावा वाला।
5 आ गया तो उसके बाद तो सारे बन ही गए ना.
हाँ हाँ, हो गया।
Is it clear?
यस सर।
Why did we choose modulo 5? Because there are 5 numbers.
5 नंबर सर।
In one of the other questions, I think the numbers are different. जैसे
हाँ,
क्वेश्चन नंबर अगले वाले में नंबर्स
5,
ज्यादा हैं.
14।
7 हैं.
अच्छा हाँ,
नो नो
वो
6 हैं.
19th क्वेश्चन में, हाँ।
6 हैं नंबर्स, राइट?
हाँ
तो देयर, ओ एक्चुअली एक पी भी तो है वो जो हिडन है.
हाँ हाँ हाँ,
देख रहे हो,
फाइंड ऑल
फाइंड ऑल
प्राइम।
प्राइम्स पी. So P is also a prime. So 7 numbers are there. So I'll take
यस।
modulo 7 then.
हम्म
सबका modulo 7 ले लोगे, उसका सेम प्रोसेस फॉलो करके आ
हाँ
जाएगा.
हाँ हाँ,
समझ में आ रहा है?
यस सर।
Okay. Uh, there will be a class for theory on Tuesday. So uh,
ओके।
after that, there will be another assignment.
हम्म
Fine. That's all for now. We'll continue on Tuesday then.
हम्म।
सारे डाउट्स हो गए ना क्लियर?
हाँ सर, एक मेरा खुद का एक प्रॉब्लम था, मतलब मैं
क्या?
कर रहा था। 1 मिनट मैं निकालता हूँ।